I'm John Heron. I'm in the Department of Material Science and Engineering here at the University of Michigan. I'm fundamentally driven by the question of how electrons and electron spin couple to the crystal structure and the lattice of materials. So we try to engineer this primarily to create new physical properties that can be harnessed in the next generation of logic and memory for computers and communication technology. The reason why this is so important is that the energy consumption from our phones, our mobile devices, and soon to be autonomous devices is increasing dramatically, and we will find that our energy supply will be significantly strained from this. And in order to support this energy demand, it will ultimately have to come from non-green sources. So my goal is to try to improve our existing communication technology and the silicon transistor by 1000x. This should allow our system, our energy system, our infrastructure to support the next generation of big data without significant demands and strain to the energy supply.
I'm really passionate about examining reaction pathways in the synthesis of new materials. Currently, I'm working with high entropy oxides. I really like the opportunity to be creative and kind of have ideas to generate materials that I think will work, and to be able to examine these reactions at a step-by-step basis to kind of understand the chemical reactions as they're occurring.
In my group, we're always looking for new, talented, creative, hardworking, and very passionate graduate students to fulfill various projects and pursue their scientific curiosity.
My project at this point involves thin film synthesis of high entropy oxides and monitoring their growth kinetics via reflective high energy electron diffraction.
I love working with undergrads. In fact, my lab has an undergrad with a project going on currently.
John kind of paid attention to my interests and kind of allowed me to have a project that I wanted to do, and pretty quickly set me up with a collaborator in Japan who shared my interests in studying these reactions. So over the summer, I'll actually be traveling to Japan in order to learn new tool technology and further investigate the reactions of these high entropy complexes.
The importance of the compound that we're looking at right now is it has really high lithium-ion conductivity and could be used as an advantageous solid electrolyte for batteries, which is good because liquid electrolytes can very easily be shorted when dendrites grow across them, or when they break, can much more easily start fires. They're usually volatile compounds. So if we could find good compounds for solid state electrolytes, we'd have much better micro batteries and safe other batteries.
So the vision for my group is that the students become leaders in their respective areas, particularly to conquer challenges in the areas of thin film synthesis and creative technologies based on innovations in materials to solve energy challenges in a wide variety of spaces.